Hi friends, have you ever downloaded code from GitHub? You follow the setup instructions line by line diligently, but somehow it just doesn't work on your machine. Maybe you lack a required dependency. Maybe the Python version is not right. Or the required runtime environment variable was set up wrong and it's not documented anywhere. I feel the pain. The first time I had this kind of frustration was a decade ago when I was trying to run a Windows XP code on my machine. And that Windows XP code was written in the last century. But luckily, it's 2025 now, and Kubernetes has been there for a while. There's already established industry-proven solution to solve this exact problem. And that's what we're going to talk about today. We're going to talk about how to pack your code so that it can be run anywhere, anytime, and on any machine. Let's get started. Here's what we will cover today. First, we will explore why we want to pack your code in the first place. Then we will discuss what exactly you need to pack. It's more than just your source code. After that, I will introduce you to containers, the industry standard solution for code packaging. We will break down two essential phases: pack your code and deploy it. And finally, we'll look into the practical tools that you will use to build containers and automate the entire process with CI/CD pipelines. By the end of this video, you will understand the complete journey from code to production deployment. So first of all, why do you want to pack your code? The very first reason I can think of is collaboration. For example, you and your teammate work on the same code base, but your teammate works remotely. How can your teammate help you? He has to be able to run your code somewhere to reproduce your code. How can they do that without you packaging your code? And secondly, it's portability. Basically, you have the situation where you want to run your code in a virtual machine or on a cluster. So you need to pack your code so that it can be run somewhere else. And next is security. When your application process external requests and handle user data, you usually don't want to expose your personal machine to potential security threats. You want that code running in a controlled and isolated environment. So the TLDR is if you want somebody else to run your code, or if you want to run your code in a machine that is not yours, you will want to pack your code. The very next question is really, what exactly to pack? So when we say pack your code, we actually mean packing much more than just your source files. Think of it like this. When you move to a new apartment, you don't just bring your clothes. You need everything that makes your life work. For your code to work, that means 4 essential components. Your application code, the actual files you wrote, and dependencies. So external libraries and packages that your code needs with specific versions. Environmental configurations. So this is where you specify programming language, what version of Python you use, environment variables, and system settings. Runtime and metadata. Usually here is where you specify how you want to launch your application. If you miss any of these, your code won't run in its new home. So what exactly is a container? Let me explain this with a simple comparison. In a traditional deployment, your application runs directly on your operating system, whether it's Windows, Mac OS, or Linux. That works fine locally. But what if you write code on a MacBook and want to deploy it to a Linux server? The old solution was to use virtual machines, essentially running a complete second operating system inside your computer. But virtual machines are heavy. They use a lot of memory and resources because each one needs its own full operating system. But that was old days. Nowadays, we have containers. Containers are much lightweight. Instead of virtualizing the entire operating system, containers share the host OS kernel, but keep applications isolated from each other. Think of it like apartments in a building. Everyone shares the same plumbing and electrical systems, but each apartment is completely separate and secure. So this makes container incredibly lightweight compared to virtual machines. You can run dozens of containers on the same machine that might only support a few VMs. And this is how exactly modern deployment works at scale. The container ecosystem has 4 key components that you need to understand. First of all is a Docker file. This is like a recipe that specifies everything we discussed: your code, dependencies, environment, and entry point. And next is the image. When you build your Docker file, you essentially create an image as an output. Think of this as a snapshot or template of your entire application environment. Next is the registry. This is like Docker Hub or AWS ECR, where images are stored and shared. It's like GitHub for container images. And finally, the container runtime. This lives on your server and does the actual work. Container runtime pulls images from the registry and runs them as live containers. So this workflow is simple. You write a Docker file, build an image, push it to registry, and then the container runtime pulls the image and create a container and runs it wherever you need. In production environments, containers don't run in isolation. They are managed by orchestration systems like Kubernetes. So here's a hierarchy. Containers, they run in pods, and pods run in the actual node, which is the machine that runs the code. And nodes are what make up your cluster. A pod can contain multiple containers that work together, and a node is essentially physical or virtual machine. Registry, as we just mentioned, it stores your image centrally. And registry, as we just mentioned, it hosts and stores your images. When Kubernetes needs to run your application, the container runtime on each node pulls the image from the registry and creates the running containers. This architecture allows you to scale from running a few containers to managing thousands across multiple servers, all automatically. Now let's look at the actual process of building a container image. So step 1 is to gather all your components, your application code, your dependencies, environment settings, entry point configurations. Gather all those and build your Docker file. So with Docker file, you specify how to assemble everything into a working image. After that, you build the image with Docker build command. This creates your packaged application. You can test your image locally using Docker run command to make sure everything works correctly. After you are confident, you can push your image to registry like Docker Hub or AWS ECR, where it can be accessed by your deployment infrastructure. So this workflow transforms your local development code into a portable, reproducible application package. Once you have your image, deployment depends on your scale and requirements. For simple applications, you can use manual deployment. Just 2 commands, Docker pull and Docker run. Docker pull so that you can download your image, and Docker run so that you can run your application using the image. This works fine for development or small applications, but for production applications that serve real users with serious QPS, you use orchestrated deployment with Kubernetes. Here's what happens. You submit your deployment configuration to Kubernetes, and the scheduler decides which worker node should run your application. The kubelet agent on that node tells the container runtime to pull your image from the registry. And finally, the runtime downloads and starts your container inside the pods. So what's the difference? Simple deployment is manual, you do the work, while orchestrated deployment is automated. Kubernetes handles the scheduling, health check, scaling, and recovery for you. But then, how do you actually build those container images? There are 3 popular solutions. So first is Docker. Docker is perfect for local development. You install Docker Desktop and build images right up on your laptop. But what if your application is large and you want to build your image somewhere else that is not your local machine? Then you have remote build, which is cloud build. Cloud build services like Google Cloud Build or AWS Cloud Build are ideal for CI/CD pipelines. Instead of building it on your machine, you build in the cloud with better resource and security. But then there's a third option, which is to use Bazel build. So Bazel build is designed for large organizations, especially with multi-languages and mono-repo. So to summarize, you use Docker for learning and local development. You use Cloud Build for production teams, and use Bazel for multi-language mono-repo. Next question is how to automate. Right? If you only do manual building, your code base gets old fast. And that is why we need CI/CD automation. There are mainly two popular options. One is GitHub Actions, the other is Jenkins. GitHub Action is perfect if your code lives in GitHub. It's free for public repositories and integrates seamlessly for your GitHub workflow. When you push code, GitHub automatically builds and deploys your containers. Whereas Jenkins is the enterprise choice for self-hosted automation. You control exactly where your code gets built and deployed, and this gives you better security and compliance control, especially important for sensitive applications. So what's the difference? The key difference is that GitHub Actions build happens on the GitHub servers, convenient but less control, whereas Jenkins builds happens on your own specified infrastructure. There's more setup work, but complete control over security and privacy. Now, let's put it all together in a complete CI/CD pipeline. It starts when you push code to your repository. This triggers your CI/CD system, either GitHub Actions or Jenkins. The pipeline then runs on 4 essential steps. First is automated testing. This includes unit tests, integration tests, security scans. And second is to build your container image from your Docker file. After that, it will push the image to your container registry and finally deploy the new image to your production environment. This entire process can happen automatically every time when you push code. Take your changes from development to production in minutes, not hours or days. And that's a complete journey from code to production deployment using containers. You now understand why packaging matters, what components you need, and how containers work, and the tools to build and automate everything. And that's it. Thank you for watching. I'll see you next time.